So now we talk about deleting nodes, and I want to make sure this is perfectly clear. We don't just randomly, hilly-nilly delete any node. We actually have to track and find which one that we really want to go ahead and delete. So I'm going to use this little guy as our cursor node that's really going to be looking through and trying to figure out which one is about to get rid of. That's a pretty good analogy. So there is some type of search that is happening first before we're having this happen. Now, cursor is not the only one that's being used in this. Previous. Remember, previous is going to walk right behind our cursor. So they're always going to be beside each other, but notice we have our cursor is going to be facing this one, and then right behind it is going to be our previous. And they're always kind of together. Previous, that's why it's called previous, is pointing to the previous node behind it. You're probably like, well, why? And that's what we'll get to here in a second. So let's pretend in our first scenario of 3 that we're going to delete the clown. We're going to delete the node at the very beginning of the linked list. So that means that number 1, that our cursor found the one we really wanted. And here's the funny part, is that previous actually was never even used. So you might not even see it on the screen. It wasn't used because we found it right off the bat. So we have to do a check. Is the target node equal to the front pointer? And the answer is yes. So what do? Well, the easiest way of doing that is moving the front pointer up 1, so now it points to the next one that's going to be eventually the front new node, being this poor guy right here. Then what do we do after that? It's actually very simple. First, I would do 2 things. Number 1, I would go ahead and set the link for this node to null just to make sure it's not connecting to anything else in the linked list. Once I set it to null, then I get rid of it. Then, after that, I'm still not done, but look at the overall linked list portion of it. Front node is pointing to our newest front node. That node's linking, and everything else is exactly the same, so we're in good shape. So notice we only worried about the front. We did not worry about the back end. Notice not much of the linked list really changed, and that's a beautiful part about linked lists. We didn't have to change a lot. We just changed one part. There's one last thing I would rather that we did, is we set our cursor, once everything is done, set that to null. And now we're done with deleting our first node at the beginning of a list. So our next scenario is we're removing a node at the very end. This is the first time you're actually going to see me use previous. Now remember, we don't just hilly-nilly say, hey, go to the end, and that's not how it works out. We use that cursor to go ahead and find it. So it looks at the first node, says, nah, that's not the one I want. Let me move up 1. Notice, here comes previous. Dun, 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 dun. Sorry. Right behind it. Then, moves, doesn't find the target, moves, doesn't find the target, moves, finds a target. So now, here's where things get interesting. How the heck am I going to go ahead and delete this one, which is not really the hard part, but make this one now the rear pointer? Do I have anything else pointing to it? The answer is actually yes. I have the previous pointer, and there's where previous pointer comes into play. So I can actually go ahead and say, you know what? I want the previous pointer, whatever it's pointing to now be the rear node. So there's a couple of steps. Number 1, if this is going to be the rear node, its link now needs to get set to null. Number 2, I need to move this sucker into place and now have it point to the rear node. Number 3, peace. Oops. Number 4 is that if I look, and I'm trying not to move this, if you look at the overall nodes and linked list setup, everything's, again, I didn't change anything here. It was only here. The rear node now, new rear node, is set to null at the very end, saying, hey, I'm the last node. Makes sense. There's 2 more things I need to do. I need to make sure I set this to null, and I need to set this to null. No arms and sharks. So that's how we would remove an item at the end, and this time we used previous. The last scenario sucks. Let's just put it that way. I'm actually going to need a little bit of extra help with the graphics than the Legos can't do. So let's pretend we're getting rid of this one. Now again, it's targeted. So you know eventually the cursor is going to travel from the front and find the target that we want. And previous is going to be right behind it. Now, how does this work out? Here's where things get interesting. Notice I do not have any links directly to this node in the middle by front or rear. So they're totally out of the equation. The only links that I have are being circled right now. And well, that's frankly all we need. But here's the funny part. I can't really delete this one quite yet. That one's going to be towards the end. And the reason is because I need to link this one to that one. So how am I going to do that? Well, remember how we did the cursor equals cursor arrow link? We're able to iterate or move forward one. Well, that's exactly what I'm going to do with this. Is that there's actually several ways of doing this. Is that I can say, okay, this guy right here, whose previous is pointing to, I want its link to now equal the cursor's arrow link, which is here. So you'd actually have at one time two people pointing to the same node. Once that is established, I can then get rid of this node because I already have that established new link that'll hop literally over the target node in the middle of the linked list. So, next steps. Set this one to null. Number 2, get rid of it. Oh, caught it. 3, set this to null. 4, set that to null. And now you have your linked list now with an item that's in the middle that was not attached to front or rear, totally disappeared and deleted from the linked list.